Our first presenter is Dr. Kevin Jones. He is the head of product and cybersecurity at the Airbus Group Innovations. Dr. Jones is also active in the cybersecurity research community and works closely with government agencies and councils as an expert, chairperson, and consultant. This morning, he will present a discussion on the factory of the future with a next generation ICS. Please welcome Dr. Kevin Jones.
Thank you. Good morning. Firstly, I would like to thank Dale. It's a privilege to be speaking at S4, and it's very good to see it in Europe for the first time. For those of you who may not be familiar with the Airbus Group, I'd like to give an initial introduction to what the Airbus Group does. Now, most of you will have heard of Airbus Commercial. It's one of the world's largest aircraft manufacturers, first or second, depending on which metric you use and which day of the week it would be. But what you may not know is that we also have within the group two other divisions, Airbus Helicopters, formerly called Eurocopter, which is the world's largest helicopter manufacturer, and a company called Airbus Defence and Space, which is providing Europe, specifically our home countries of Germany, France, and the UK, with cybersecurity capabilities. We provide SOC operations to military, and they provide critical national infrastructures across Europe with cybersecurity advice and solutions. I have a very interesting role within Airbus Group in that I head the Product and Cybersecurity Innovations Group for the Corporate Research Centre. Now, that means that I don't work for any of the three divisions. Where I actually work is at group level, and what we are tasked to do is to bring state-of-the-art innovation, whether that be external capability, external product, or innovate ourselves to add value to the Airbus Group across all platforms. Now, one of the key areas for us as a manufacturing entity is to protect our industrial control systems. And in order to enable us to do that, we actually have in the UK and in Munich one of Europe's best industrial control system security research labs. So we want to make sure that we are testing, validating, and innovating in the area of industrial control system security. So as one of the world's largest manufacturing companies, it is critically important for us that we protect our own systems. Now, what you're seeing here is actually some of our labs. For Airbus Defence and Space, we mirror critical national infrastructures, whether that be water or smart grid, some of the Modbus demonstrators in the middle, but we also mirror manufacturing. So we have mini production lines or KUKA robots in the line there. And actually, the talk I want to talk to you about today is a little different, in that normally I would come on a stage and talk about where we are in terms of industrial control system security in Airbus, where we are in terms of innovation, where we are in terms of being able to protect PLCs, RTUs, manufacturing control lines. But Dale set me an interesting challenge. And one of the other things about innovation is that we have to be looking to the future. We have to see what's coming over the horizon. So I started to think about factory of the future and industry 4.0, depending on where you are in Europe. So for us, it's very important that we actually look at not only the ICS of today, but the ICS of tomorrow. And we are looking already to be able to provide the security solutions by design of those infrastructures. But let me just give you a little introduction, a little use case on where we are today and why, in fact, we're looking at Factory of the Future or Industry 4.0. So, as I said, Airbus Airbus Commercial is the world's first or second largest manufacturer. We have 11 production sites for components and 5 assembly lines for various forms of aircraft. Majority of those are here in Europe. We do actually have a final assembly line freshly built last year in Mobile, Alabama in the US. We also have assembly lines in China. So we are truly a global player in this market. Our production lines are complex, very large scale, and we rely heavily on a just-in-time supply chain. So components that will be, for example, for our A380 in Toulouse, will arrive ready for final assembly line via the Beluga, which is our owning aircraft for shipping components, or via land, sea, and they'll arrive just in time. We are a labor-intensive manufacturing industry. So to create an aircraft, we create a high-quality, safety-critical product. And in order to do that, we have a very labor-intensive, very quality assurance process. And it's precision engineering. So what I'm going to talk about is very much based around manufacturing. So some of you in the audience perhaps may be more in the C&I space, water, gas, electric. Yes, I'm aware I'm going to talk about manufacturing, but a lot of the components and a lot of the innovation that's coming in our space is also going to apply to you in the future. The metrics you have here are very Airbus commercial centric. But in the previous slide, you saw just how big our group actually is. So we have Airbus Defence and Space, which manufactures the A400M military aircraft. We also produce a large number of components for the Eurofighter, along with some other partners. So it's not just our commercial aviation business that produces or manufactures aircraft. We also have Airbus Helicopters, which is one of the world's largest and Europe's largest helicopter manufacturers. So we have very different manufacturing requirements across the whole business. Aircraft is very lean, very production-oriented in terms of we have fixed jigs, and an aircraft component will move between jigs, whereas a helicopter is much more static in terms of what is required. Now, as a cybersecurity researcher and leading the cybersecurity team, one of the things we have to do is advise the business on risk and on who may be targeting us. And it's very interesting in the ICS space. We see a lot about Stuxnet. We see a lot about Havex and the technologies that are being used by the adversaries to target ICS. But the first thing to do from an industry perspective is to actually assess our risks. Why would people target us? What type of thing would they be doing if they were to target us? Now, we've published a paper in 2014 at a conference looking exactly at this problem and trying to assess what the motives of an adversary would be. This is slightly generic in the C&I SCADA security space, but I will make it Airbus specific for you. Insider threat is probably still one of the biggest problems we face today. People who have access and complete control across SCADA infrastructures. Now, if I was to look at the control systems within Airbus today, we're very, what I would call, enclave focused. So it's manufacturing, it's a jig here, then the component moves to another jig. So it's very difficult for an insider to have a prolonged and sustained effect by targeting or attacking an industrial control system within Airbus. But it still doesn't mean it's not a credible threat or a credible risk to our organization. The majority of insider threats actually are mitigated through quality assurance. Our quality process makes sure that what comes off through that enclave is still a good quality product and can be used elsewhere in the production line. But if I was to look at some of the infrastructures that we know of within perhaps the UK critical national infrastructure, where it is true SCADA, it's distributed, controlled, widespread, then the insider threat is a very big risk to those organizations. They have complete control over the infrastructure, and wittingly or unwittingly, we've seen time and time again the insider being the main route into a critical national infrastructure or a SCADA system. The second type of risk that we would look to consider is hackivists. Why would you target an industrial control system as a hackivist organization or an anonymous type organization? Well, at the moment, if I'm being quite frank, from the research and from what we're seeing, we're not seeing large-scale, wide campaigns against industrial control system. We do, however, see in Kali Linux or other areas industrial control system components. So hackivists generally are having too much fun stealing your credit cards. They're using ransomware. They're trying to make money. But we still should consider carefully the fact that there are campaigns for anti-military or other areas of anti-government sentiments that would lead to hacktivist groups having the capability. And we're seeing automation in tools that will target ICS. So for us, that's very important. The third area is spies, industrial espionage. Now, this is something that's very common in what I would call IT security. Confidentiality is key, right? And industrial espionage is an interesting topic for ICS. Why would you look to do industrial espionage on ICS? It's complex, it's difficult, you can steal plans, you can steal manufacturing documents from the IT environment. Now, in a previous guise, I also worked as a consultant in ICS cybersecurity. And I happened to work for a petrochemical company or was working alongside a petrochemical company. And they were very proud in telling me that, in fact, they had a heavy investment in IT security. They couldn't steal any of the secrets of their manufacturing process. And actually, I pointed out that there is one place, in fact. They used secure zonings between different countries. So only certain parts of documents would be in different countries. But on their manufacturing lines, there was all of their secret source. Not only what was involved in producing that, but how to produce that. And even as Airbus, we look already to competitors in, for example, China, who are producing the next generation aircraft. But one of the real key difficulties in producing an aircraft is how to produce an aircraft, not the design of the aircraft. That is important. But how to produce it, how to produce something that is, how to manufacture it so it's safe, so that it's high quality. Industrial espionage and industrial control level is one of the only areas whereby you can actually take everything in one long shot. Cyber terrorism, so depending on what type of industrial control system environment you're actually operating, cyber terrorism could be a real problem for you. We work very closely with the nuclear industry, for example, who take cybersecurity of ICS very, very seriously. They segregate, they use other areas, but what they're really worried about is cyber terrorism. Can somebody take an automated piece of malware, specifically targeting ICS, and push it into an ICS environment? We've seen already that traditional IT malware, mainly in and around the German steel mill incidents that were announced in the last year, how traditional IT malware can impact functionality of an ICS. But if we have a very targeted attack, something HAVEX related in the smart grid, then we have to look at cyber terrorism. And finally, what I have to be very careful in how I describe, very sophisticated, very targeted, highly resourced, highly funded type of malware. Now, this is probably more of a problem for critical national infrastructure operators. We've already seen in the last 12 months people targeting power grids, people doing intelligence gathering of power grids, people targeting nuclear enrichment facilities, for example. And these are the type of attacks that are very, very difficult to defend against. Okay. So, where are we today and what are we doing? Well, there's lots of things that we can actually do to help us protect our OT environments of today. We can start by looking at security architectures. There is a plethora of architecture documents, standards documents out on the market. And as Airbus, we actually are taking the best practice from all of those security architectures, and we have our own. So in our industrial environments, we have good segregation. It's clearly a key step. We have isolation in terms of making sure that our enclaves are not connected to anything else. But as part of those architectures, we should also consider the fact that they're operating manufacturing facilities. So there are times when our suppliers, for example, Siemens or KUKA or those, would want to do remote maintenance. And considering the fact that we know that these entities need access to our facilities, how do we facilitate that in such a way that it maintains security? So one good way in our security architectures is actually not to allow them direct access to our ICS. We always have a man in the middle. So from an innovation perspective, we have to make sure that we are taking and always considering the best practice from security architectures. One of the things that always baffles me and rather perturbs me in terms of some of the recommendations is they're still very much based around IT infrastructure practice. If I look at some of the standards and some of the security architectures that are proposed, I have a firewall, or I have a DMZ with a historian and HMI passing data up through the different infrastructure layers. And I'm going to come on to this point later on. But in the architecture, you should really consider carefully an ICS environment is based around functionality and safety. So a security architecture in a traditional IT world is actually considering confidentiality, integrity, and availability. They are your primary goals. But in an ICS, I want it to produce an aircraft component, or in a CNI space, I want it to produce power. So functionality and safety are king. Underneath that, then we may have CIA. But in the security architectures, we should segregate. We should be able to produce various elements. SOC. How many of you monitor your ICS? And I mean genuinely, truly down at your ICS level. One of the key areas of innovation for us, and one of the key areas that we're seeing from suppliers providing in this space is SCADA SOC. It's very easy to take the perimeter of a SCADA environment, the firewalls, the edge points, the routers, dump those into a SOC. You may even potentially have some SOC plugins that allow for SCADA protocols. But actually, how do you monitor right down at bus level? How do you monitor communications between a PLC and an RTU or a PLC and a HMI? For us in Airbus, actually, that's something we'd quite like to do. And we have various components and various elements that enable us to do that. Time sequencing, enclave security, bring it right down to the factory floor in a way that people can understand. There are an increasing number of products that will enable SCADA SOC. We actually currently have 7 IT-related SOCs. For the first time this year, we're looking at integrating our OT, our SCADA environments, into those SOC environments, so that we can monitor for not only behaviors coming through the edges and the endpoints, but we can do very specific network monitoring at bus level. And the more IT and OT integration we can get, the better. However, that gives us a slight problem. Because if we look at our SOC analysts, they're very good at IT. They're very good at understanding what this piece of malware looks like. They're very good at understanding what an anomaly looks like on a PCAP file. But actually, what I really want them to do is tell me what the impact on a OT environment is if I see something anomalous in an OT PCAP. So we're also looking at training SOC operators appropriately. And then that leads to the next step, which is, well, if you do detect something, what do you do about it? How do you actually respond in a SCADA environment? The first problem you have is scale. So I will take one example, which is our Hamburg production facility. One of the interesting things about Hamburg is, from the moment you get to the front gate of our assembly line in Hamburg, it's a 10-minute bus ride to just a few sheds away. That is a huge scale. And if I look at the way that incident response works in IT, I already have usually something I can begin timelining from. It's a web-based interface or something along those lines, or it's anomaly detected somewhere within the infrastructure, or it's a snort rule that's fired and triggered. But in an ICS space, is that even possible? So we published in 2014 from our research department one of the first incident response for SCADA papers. And we considered carefully scale, but we also considered the fact that we're working in an OT environment. So quite frankly, somebody is going to be ripping and replacing a PLC. Somebody's going to be reprogramming and uploading logic to that PLC. So how on earth do you come in as an incident responder and go, I want to be able to recover data from that device? It's too late. It's powered down. It's gone. The system's back up and running. Functionality is king, remember. So the procedures that we wrote for internal use and published are very much in response to being able to do forensic recovery in an OT environment. Incidentally, the tools to actually do forensic recovery from a PLC, for example, don't really exist yet. So it's a bit of a problem. But we often hear in the CNI space, or when we talk about how big is the threat to industrial control systems? How big is the risk to industrial control systems from cyber attack? And people generally don't invest or don't do things. And one of the problems is because we just don't know. We don't do forensics properly. We don't know how to recover the intelligence and the information. So we are doing that internally as Airbus. We're building a good picture. But what of tomorrow? That's where we are today. That's what we're doing. That's how we protect our systems. That's how we protect ourselves. What of tomorrow? Well, we're talking of factory of the future or industry 4.0. Now, there's a good rationale behind why we need that. We currently have about 30,000 deliveries planned over the next 20 years of aircraft. There's a slight problem in our model for aircraft in that we have orders for the next 10 years, but we don't get paid until we actually deliver that aircraft. So we need to increase significantly the efficiency of our production lines. Today, we currently produce around, let's take the A320 for an example, about 48, roughly, per month of A320s. In order to even sustain our targets based on what we've already sold as aircraft, that needs to increase to over 60 per month by 2020. And that means that we need to really innovate in this space. So, that's the rationale. Currently today, manufacturing lines are labor intensive. It's highly skilled. Our operators are very well trained in terms of producing an aircraft component or a final assembly. We're very much driven by performance, weight, aerodynamics, design, production, etc. We produce a safety critical product, so not only is the quality of the product required, we also have safety in our manufacturing lines. And we have very large purpose-built jigs for each device, whether that's painting or whether that's assembly. The jigs are there. And I'll give you some context because it's only fair. Millimeter accuracy is required in our manufacturing lines to ensure that quality. Now, in order to gain millimeter accuracy, one of the things we need is to make sure that the jigs are stable. So we drill down into the ground. Foundations of the jigs are deep underground. Every time that we have a manufacturing line that will, or a new manufacturing line or sustaining manufacturing line, if I was to drill down, there is millions of pounds invested purely in making sure that jig is stable. So, that's where we are. And that's why we want to do it. Just as interest, if you compare us to car manufacturing, we're quite low rate. We only produce a few hundred or a few thousand units per year. So it's very sustained. So where are we going? Well, we'd quite like high production rate. We'd quite like 60 plus aircraft because that's what we're going to sell. We'd quite like high customization in terms of our customers being able to decide what their aircraft looks like and be able to embed that into an aircraft very, very cheaply. High ramp-up speeds. We would like automation, so we'd like our operators to be much more effective and efficient in what they do with cobots, for example. And cybersecurity is absolutely one of the key elements of what we do. So, what I would like to do is show you a short video in a second of what we envisage as the factory of the future and where it goes. Now, we actually have a center called the ZAL in Hamburg, which is where all our factory of the future research is undertaken. And it's 300 million euro being invested right now to help us achieve our goal of 60 plus aircraft per month delivery for A320 and how we go about doing that. So one of the good news is cybersecurity is at the heart of ZAL. If we're going to create the next generation systems, if we're going to create integrated systems, they've got to be secure. They've got to maintain the quality of our product. So we are right there at the beginning. Now, the idea of Factory of the Future is that we have full integration across the life cycle. Shop floor. So automated tooling comes from SAP right down. Enterprise automation, engineering through to in-service and full integration. So, here's our vision of Factory of the Future. I said earlier that it costs millions to be able to drill down into millimeter precision of our jigs. What if that could be automated? What if that could be digitalized? What if sensors could determine that millimeter precision. And that's where we're going to have our lines. It saves us millions in our manufacturing process. Customers want automation. Customers want customization of their aircraft, what it looks like, where it is. At the moment, that's very expensive for our customers because each aircraft that comes off the line has to be designed. In the factory of the future, we actually don't want that to be a problem. A customer, straight from design through to shop floor, through to aircraft and out the door. That means that we then have data-driven technologies that pass through the onto the shop floor, the components, the design, the manufacture, everything ready for just-in-time delivery to an operator who's going to build the manufacturing lines. You've already seen AGVs. So AGVs is really at the heart of it. Mobile, working, delivery just to the right place. This is a fundamental shift in how we do manufacturing because actually the shop floor changes rather than the component moving around. So rather than having a fixed jig, well actually I can move the component around or I can move the jigs around the component. Major component standard equipping. So just-in-time delivery of all of our components right through to the end operator who's going to build our aircraft with ready to deploy, ready customized, ready tooled components for audit and manufacture. Smart tooling. So this is now very much in the IoT space. Wi-Fi connected tooling. We already have some of this, if I'm being frank. So one area for us is the design will come down and a torque on a screwdriver will determine what rivet, where on the aircraft. It'll be augmented reality over the top. But the factory of the future really is going to do that. So I can walk up to any aircraft component with a smart tool, Wi-Fi connected, and it'll do exactly what it needs to do to produce that high quality component. Robotics, standard equipping. So you can already see there on the top of the aircraft. Miniature robots working in and around, cobots working alongside our operators and our engineers. High efficiency, high quality. Embedding into the aircraft itself, communication lines, software systems. So the current trend is for more interconnectivity, more offboarding, more passenger services, and that requires wiring. So very much in the factory of the future, we're going to be able to design and integrate into the aircraft those wiring circuits on the fly. Automated assembly. So cobots, direct delivery from end to end. Has anyone noticed yet that this is all very data-driven? So it's a very nice vision of paint shops and design and engineering and full integration. The thing that underpins this is data. Right from component through to engineering, to manufacturing, to quality. The second thing that underpins all of this is communications. So I have to have a fully integrated system, a fully integrated environment. Now this gives us a real problem in terms of security. So when we look at what the future aircraft manufacturing will be, we have 3D goggles, we have smart tooling, we have paperless office, people with a wrist monitor that says exactly what that infrastructure will be. Data to the engineer who's building an aircraft. And it's a grand vision. And I have to say that this is the only time in my career that I've been able to say to Airbus, cybersecurity can save you money by doing this right now. If we look at the life cycle of the costs for implementing cybersecurity, most people do it towards the end, build, test, deploy. This is standard IT. Fortunately for us, we are directly involved in the ZAL in Hamburg, embedding cybersecurity into the future of aircraft manufacturing and IoT. So we hope to be able to make sure we reduce those costs. So what does that mean? What is the next generation system going to have a problem with? Well, the first thing is traditional SCADA for manufacturing has a perimeter. We have an air gap, or we certainly have perimeters and enclaves. Well, that's gone, because in the future factory, we have our supply chain fully integrated. We have ALM manufacturing that comes to production line through to our logistics. We rely very heavily on interconnectivity. We rely heavily on smart tools, smart maintenance. Big data underpins all of these IIoT and cloud. And we have cobots, so robotics working alongside the human. But you're a cybersecurity audience. So you know my problem when Airbus first came to me and said, this is the factory of the future. And I said, please consider cybersecurity. Because where do we stand? If I now have no perimeter, if I now have fully integrated components and areas, if I now have a supply chain that's direct access to my facilities, the first thing is I need to protect and maintain functionality and safety of that production line. So I have to make sure that the sensors can't be manipulated, the components can't be manipulated, the cobots can't be manipulated. And one of the things we can already show in our lab, well, logic on a PLC, you can re-upload logic on the fly. You can change memory values that change the behavior of a PLC component. So for Factory of the Future, when I no longer have this air gap, how do I protect it? Control manipulation is a problem. Quality, we have to maintain it. Functionality, manipulation also is in there. So, security architecture, absolutely required, absolutely key. Data protection mechanisms. So this is one of the other things that we consider. ALM, or 3D printing, effectively, of components. How do I make sure that ALM in the supply chain retains the confidentiality of those components as I issue it out in the supply chain? So one of the great things about Factory of the Future is as I 3D print, I can mesh various components in together and have a very good economy of scale. But actually, I want those components to still be confidential in their design. So how do I protect those? Loss of control. How do I prevent those? How do I prevent people targeting or directly manipulating control devices, cobots, and various elements? Monitoring. Let's take monitoring forward. Let's really innovate in this space. I'm starting to see a lot of elements of SCADA-related SOC, SCADA-related asset discovery tools. It's missing. For Factory of the Future, for today, it's still missing. How do we truly innovate to be able to detect an attack on a SCADA system? Some of you will be aware that only last week, IonKey came out, and it works in a synthetic environment, but doesn't work in virtualized platforms. So Cuckoo, sandboxing, for example. So actually, how do we really detect the areas and the elements that are working in that area? And protection of risk. So for us, as we move to Factory of the Future, we consider the risks up front. We consider openly what security mechanisms that we need. And we work with the supply chain on that area. We work with KUKA, we work with Siemens, we work with all of our suppliers to be able to manage that risk appropriately. Not only in the systems that we are looking at for the future, but also in our current legacy systems. We're not going to build entire new A320 manufacturing lines. Some of them will be new, some of them will be legacy. There will be integration between the two. So how do I segregate? How do I make sure that what we have in the lines is not transferring that risk? And my final slide, I applaud you to innovate in this space. What I'm seeing predominantly in terms of OT security solutions is IT security solutions with the word OT stamped on top of the solution, on the box. It's really, really frustrating because they don't understand the functionality and the safety requirements of OT. You don't understand the fact that we don't necessarily have a span port on a server, on a switch, to be able to generate all the data. So how do I protect legacy systems of today? How do I protect big manufacturing lines of tomorrow, considering carefully what Factory of the Future is going to offer, what industrial IoT is going to bring to us? Fully integrated, fully harmonized, data-driven technologies. We're going to be exposed to the risks that currently exist in IT. We're going to be exposed to more bespoke malware. We're going to be exposed to customized, targeted attacks. If we look at what happened in the German steel mill incident, actually everything that comes out says that wasn't really a very sophisticated attack. What came out was traditional IT attack tools and methods with some customized SCADA elements. So how do we protect ourselves from those as we go forward? And that's where we are going. I will take Q&A if I still have time.
Thank you. So we have time for a couple of questions. Do we have one in the audience? Please introduce yourself.
Hi, my name is Lucian Constantin. I'm a news reporter with IDG News Service. You mentioned that you've started integrating SCADA systems with your SOC monitoring tools. Can you share anything about what you've seen so far? Like maybe if not specific attacks, like their number or frequency and things like that. Thank you.
Okay. So what I've presented here is very much the vision for the future in terms of Factory of the Future and full integration. Where we are today probably is of more interest to you. We have a lot of enclaves, a lot of distributed systems, a lot of offline systems. And like many manufacturing companies, one of the only areas we have for information is the edge points, the perimeters, the firewalls that are coming through into our environments. We have offline environments, which is one of the key security mechanisms that we have. So we do monitor carefully those who have access in terms of physical access to the environments. But actually what we need to do more of is look at the bus level, so the OPC code, the various elements of the SCADA infrastructures that are in the manufacturing lines as we move forward to developing the systems of tomorrow. We, of course, as with any other organization, are targeted. We see various amounts of attacks coming into our IT infrastructures. We see certain elements of attacks coming into the perimeters of our OT environments, but we are very much aware that what we make is a safety critical product. So actually, we're very good at making sure that anything that comes through the perimeters doesn't come any further into the main manufacturing lines. One of the advantages we currently have today is that actually it's a very manual, labor-intensive process. But as we move forward into the Factory of the Future, then it's absolutely key that we make sure that the digital interconnected networks that are going to drive Factory of the Future are secured and monitored as well. So in our manufacturing lines, no. So I'm going to split your question slightly. So at the beginning, I introduced Airbus and Defence and Space. So for the Airbus in our own production lines, we do monitor, we do look, and we haven't seen anything that's specifically targeting our manufacturing, for example. If I take that hat off and put more the, as I say, Defence and Space hat on, so it's very much in line with critical national infrastructure and what we provide to those, then we know that there are tools and automated tools out there that are targeting industrial control systems. Havex, for example, is fully automated, ready to go, mainly targeting power grids. to a certain extent. It happens that the US has been mandated to monitor its power grids for far longer than anyone else, so it's no relation that the data shows that HAVEX has a very big influence. So there is this increase in industrial control system malware. There is an increase in interest in people targeting industrial control systems, mainly in and around critical national infrastructures. But just to be clear, we still monitor carefully our production lines, but we're not seeing anything targeting or specifically looking at those.
Marina Krotofil, Honeywell. I really very much like how you highlighted that we have almost like little to no visibility into the lower levels, like level 0, that's physical process, like 1 and 2. So, especially like I see that how the easiest way to get there for the attacker is probably supply chain. So what is your strategy? So first of all, to ensure that the devices which you get rootkits, backdoors free, because for now, for the attackers, it's much easier to write rootkit for firmware than an operating system. And how are you working, are you developing capabilities to work towards like finding rootkits on those devices, monitoring the integrity of the current devices?
Yep. That's a very, very good question. Supply chain management is one of our key areas of investment, actually, on the OT space. Making sure that the components that come through into our OT operating environments are tested, are validated. We have a dedicated red team that will actually make sure that the components that come through into the environment are, prior to deployment, in fact, are tested and validated and secured. Actually, what's very interesting is it's not just supply chain in terms of the components that are deployed. It's the supply chain, and this is what people often miss, in terms of the services that go around. So there are times when we send back components, for example, for routine maintenance or for servicing. If something breaks down, we'll send it back to the supplier and they'll come back with a new component. We have, using our processes, our security processes, already found times when, for example, there's been what we would consider unauthorized updates to those components. So whilst it's been there for a maintenance cycle, they've said, oh, we'll put the latest patch or we'll put the latest version on. Now, there's nothing malicious necessarily about that. It's a pure update cycle. But it's interesting that one of the areas that we're very, very focused on is actually enabling our supply chain to understand what our needs are, to enable that we put requirements on our supply chain to inform us of what they're doing, to enable us to test the components that are coming into our industrial environments. Now, that's where we are today. We've looked already at the next generation factory of the future, and I think that's going to be an increasing challenge because we're going to enable more of the IT world in the OT environment. So in IT, well, I patch every Tuesday. Where's the problem? In an OT world, actually, I don't want you to do that. I want to really make sure that that patch is validated. I want to make sure that we have somebody in the loop that does that for us. So as Factory of the Future, I think that's an increasingly challenging problem for us and one that we're certainly looking at.
Okay, well, thank you very much, Dr. Jones, for the keynote. Give him another round of applause.